The CCM 300 was designed to overcome the limitations of existing chlorophyll content meters to work with almost all plant sample types. Samples that cannot be measured by traditional chlorophyll content meters can be easily measured with the CCM 300. It can be used with a single white pine needle or other conifers. It can be used for recently germinated rice, immature wheat, moss on rocks, or cactus. It can also be used on recently germinated Arabidopsis leaves. It can be used for cam plants, fruit, algae on rocks, lichens, and seeds. The CCM 300 is also capable of measurement averaging used in nitrogen management. Averaging values from 2 units to 30 units are possible. Here we show the averaging capability on turf grass. 5 measurements will be made, and the averaging ratio and chlorophyll content will be displayed along with individual measurements. So how does the CCM 300 work? The CCM 300 uses ratiofluorescence. The research regarding the use of ratiofluorescence for chlorophyll content is well established. In addition, the advantages and limitations of the technique are well understood. Until now, the cost of ratiofluorescence systems has been prohibitive. Opti-sciences engineers have solved this problem. After reviewing the research and testing various samples, the 735-700 ratio from Gittleson 1999 was chosen as the best solution. This ratio offers by far the largest reliable chlorophyll content measuring range available. It measures 41 milligrams per square meter to 675 milligrams per square meter. These graphs are from Gittleson 1999. On the left, the graph shows the very tight correlation between the 735-700 ratio and chemical chlorophyll content measurements. On the right is a graph that shows the direct readout of chlorophyll content using the formula developed in his paper compared to chemical chlorophyll content measurements. The finer lines on each side of the trend line represent 1 sigma standard deviation. This graph represents the results of a measurement taken every minute for 15 minutes at the same location. It shows that the measurements are highly repeatable, that there is no significant Kotsky effect due to the use of low-intensity modulated blue light, and that there is no significant effect caused by light or dark adaptation. These are the advantages of the 735-700 ratio versus absorption-style meters. With this technology, plants can now be measured from germination to maturity. It works with much smaller samples, and critical sample alignment is not necessary on medium-sized samples. The measuring aperture does not need to be completely filled to measure reliably, as required by other meters. It works very well with smaller curved surfaces like pine needles. Light transmission through the sample is not required for samples like cactus, seeds, and fruit. It also provides a much larger reliable measuring range than other types of meters and much better repeatability. For more information and pricing, contact opti-sciences or its distributors.